Good evening. We're going to do a introduction and walkthrough of the Netonix WISP Switch product line. The particular model that we're going to log into first here is a WS12 250AC. This is actually one of my favorite models that we sell because it's very small. It's about the same size as a Ubiquiti Tough switch, but it has 12 PoE ports, 2 SFP cages, a total of 14 ports with 250 watt PoE budget. So if you use your browser and you go to the IP address of the switch, this is the logon splash screen that you'll get to. So I'm going to go ahead and log on here. That'll take me to the status tab. So we'll start here at the top and work our way down. The upper left corner is basically telling you the model, the name of the switch. This switch happens to be the one that's in the RF Armor Netonix warehouse. So it doesn't do a whole lot, but it's here, and it's in New Holland, Pennsylvania. This here is what we call the Christmas tree. The Christmas tree is just basically a little simple graphic representation of the switch, but it gives you a lot of information at a glance. For instance, the SFP stacks are dark gray and black right now, which indicates that there's no SFP module present. So that's why they're there. If there would have been an SFP module in here, the outer shell would be a light gray. And if there was a link, the center would be a color. Red stands for 10 megabit, yellow is 100 megabit, and green is gigabit. So we come over here to port number 1, and it has a green outer shell. That's telling us that it has 24 volts standard. That uses pairs 3 and 4, pins 4, 5, 7, and 8, where 4, 5, pair 3 is positive, and 7, 8, pair 4 is negative. And of course it has a 100 megabit full duplex link. That's powering a Ubiquiti NanoBridge M5, and that's how we're getting the internet here at this office. So the orange one over here on the right is telling you that it is a 48 volt standard, once again using pairs 3 and 4, pins 4, 5, 7, and 8, pair 3 for positive, pair 4 for negative. That's powering an 802.3 AF SIP phone. That's the phone here for the warehouse. So you can power active PoE devices with passive switches. You just have to manually turn the power on for the port. The gray squares mean there's no power. Black means there's no link. Of course, this one here is gray, means no power, and it has a link, 100 megabit. That is the FXS port for the PA intercom system here. That's how I phone in here during the day and annoy the employees and say things like get to work. Alright, over here to the right, since there's no port selected, it's telling you the total throughput and total packets per second that the switch is carrying, and the total power usage that the switch is delivering, including the power that it's using for its switch core and fan. If I select a port, such as that one, then this changes up here, tells you that that's 24 volt, how many watts it is, and then the bandwidth and packets per second and link speed for that port. So that's pretty much the top. And now look here inside the tab. First column is port number. That's pretty self-explanatory. The description, which you can set later on the ports tab. The next column is the link column. So it's telling you what each port is linked up at. If you see this little FC to the right, that's telling you that flow control is turned on the port and that it has negotiated flow control with its partner that it's connected to. So even if you turn flow control on, if the device doesn't support flow control, there's no flow control negotiation there. So if we look down here, for instance, for the Ubiquiti cameras, these are the older AirVision cameras, they don't support flow control, or at least with the version of the firmware that I have on them. And I haven't checked to see if the newer firmware would support flow control. The next column is PoE. That tells you what PoE option you have turned on for the port. 24 volt, obviously, for the Ubiquiti NanoBridge. The Unify also, this is just the standard Unify, 24 volt. That's how many watts it's using. The workstation that I'm at, this one right here. I'm actually doing this little video from the shipping workstation. Since it's late at night, there's nobody here using it. Of course, there's no power usage. And you can work your way down and see the rest of the PoE and voltages. TX, RX data, pretty standard. TX packets, pretty standard. Errors, of course there should be no errors. If there is, if there are a lot, you need to investigate why. The little gear here allows you to switch between excuse me, between raw data numbers and human readable numbers. And then you could also reset the counters if you so chose. Each port row has a gear at the end, which you can click on. That would let you run cable diagnostics, port bounce. If I did a port bounce, it'll warn me. It'll say, hey, you're about to turn power off. Do you really want to do that? It'll just turn it off for 5 seconds and back on. So if you wanted to reboot a device, it's a quick and easy way to do it. The port details will give you a detailed sheet on all of the different packets, types of packets, any errors that you're getting on the interface. So it's nice to have these little bits of information when you're trying to diagnose a problem. There's another option here, which I'll do on this one, which is cable diagnostics. If you run cable diagnostics on anything less than a 1 gig port, it will disrupt communications for a few seconds, so it warns you. If this was a 1 gig interface linked up, it wouldn't even bother me. It would just start doing the test automatically because it wouldn't interrupt communications at all. Well, we'll go ahead and we'll interrupt the Unify. There's nobody here walking around with their tablets at this hour. So what we got here was pair 1 and 2 okay, pair 3 and 4 short. That's because Ubiquiti is only using a 2-channel transformer. They're not using a 4-channel transformer for the Ethernet with center tap. So they're just pulling the power right off of the pair 3 and pair 4, the blue and the brown pair. And they kind of connect them together, so that's why it says short. So a short is okay in this situation because they're just bonding the blue-white and the blue pair together and the brown-white and the brown cable together to carry the DC voltage. We did get a difference of opinion here as to the length of the cable. Sometimes the cable diagnostics test will give erroneous answers like any other cable diagnostics test. So just like when you go to a doctor, if the doctor says you're healthy, you usually say, okay, great, and you leave the office. But if he says you're going to die, you go get a second opinion. So let's go ahead and run this test again and see if those pairs come up right. And they did. So you should always have the same length on your pairs. If you don't, something's wrong. And either the cable was stretched, which changes the crosstalk between the pairs, the attenuation, or maybe an end is crimped wrong. So you should investigate any time that you have mismatch in pair lengths. So down here is your total throughput, since no port is selected, although you can select a port. And if you select a port, then the graph changes to that port and gives you the packets. You can come over here and select a 5-minute graph or a 1-hour graph. The nice thing about our switches is as soon as you log in to the switch, it has 1 hour worth of data. Okay, I think we discussed that. So this is pretty much the status tab. The heads up here or the Christmas tree. And we're going to go on to the ports tab. Now in the ports tab you have the port number, which is pretty straightforward. You can enable or disable the port communications by unchecking that box and applying it. This is where you give the port a description so the next guy coming along knows what's in that port. This is where you set what you want the speed and duplex to be. Realistically, you should always say auto unless you're forced to set a speed. You always want to use auto because a lot of protocols such as flow control and stuff are tied to that. And for best communications, you really want to give the switch and the device you're talking to the ability to step down if necessary. This column over here is the PoE options that you can assign to each port. The first 4 ports in this switch are special ports. Means that you have 24 volt standard using 2 pair. But you also have 24 VH, which uses all 4 pair, and you can deliver up to 1.5 amps. This is pretty awesome for the AirFiber X series. As far as I know, we're the only switch in the world that delivers 24 VH, especially at that current level. You can select 48 volt standard, that's 2 pair, 0.75 amp, or 48 VH. Now that would be used for AirFiber 5s or AirFiber 24s, and up to 1.5 amps, which you can also use this feature here to power our mini switch, which we'll take a look at a little bit later. If you try to change the PoE option on something that already has a link, those options will be grayed out and you can't select them. The switch is basically saying, hey, I have a link, I'm delivering 24 volts, so I don't want to change the voltage. You can turn it off, of course that will drop your connection, but that's the only thing you can do once you have a link. So now if you come down past the 4 special ports, you see all of these ports have 4 options. Once you come past that down here, say port 5, you only have 24 volt and 48 volt standard, and that's all you have the whole way down to port 12. So those first 4 ports are your special ports, and you want to reserve those for AirFiber 5, AirFiber 24, SAF, Exalt, other high-powered radios. You can power AirFiber X's with our standard ports, which is standard 24 volt, but you want to limit your cable length to about 150 feet plus or minus. Depending on the quality of your cable, you might be able to get a little more or a little less, but usually 150 feet is a good safe number to power an AirFiber X with a standard 24 volt option from our switches. The next column is PoE Smart. It says PS up here, but if you mouse over it, it'll tell you it's PoE Smart. PoE Smart is a nice feature. It will help you prevent an oh crap moment where maybe one of your employees or yourself crimped an end down wrong. And that's where we talked about earlier, a cross short between pairs. So if PoE Smart is on, then when you go to apply power, it's going to check it first. So I'm going to select 2 here, and I'm going to go to apply 48 VH to it. And then I'm going to go up here and hit Save and Apply. And you notice here in the Christmas tree now it turned red, which is telling you that there's 48 VH on that port, so be careful. If you plug something into it, it could damage it if it's not ready to accept that power. But let's go look in the log, why don't we? So let's go real quick and jump over to the log. And we want to come down to the bottom, and you can see here in the log, PoE enabled on port 2. PoE Smart is checking the cable, and it did the result that it came back with, which was open, 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 which is correct because there's nothing plugged into it. So it says, okay, PoE Smart approved this port for power, so it's turning the power on. If there was a short on that port, a cross short, I should say, between pairs, PoE Smart would have rejected the option to turn on the power, and it would have immediately turned it off and let you know. Say, no, you can't turn power on. But, you know, don't rely on PoE Smart. It's just there in case you forget a step, but I always tell people before you apply power, make sure you run the cable diagnostics. Running the cable diagnostics is going to tell you that everything is good. Open, 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 open. Of course, 0 because nothing's there. But you know, you should always test cable run before you turn the power on. And you can do the cable diagnostics with the device hooked up without power, although you'll get different information per pair based on the device. Sometimes you'll see abnormal termination, sometimes you'll see a short, which we described is fine on pairs 3 and 4 as long as you don't get a cross short. And let's go ahead and say save and apply on that, turning the PoE off on that port. So that's the PoE Smart function. I really advise you leave it on. We do give you the option to turn it off in case there's something that it doesn't work with completely and it's causing you grief. You can turn it off. The next column is flow control. I've given a lot of people information about flow control. It's on our forums. You can visit our forums at forum.netonix.com. That's forum.netonix.com. There's a good thread in there that was started by Matt Hops called Flow Control Take 2, 3, 4. And you should start at the beginning of that thread. It's quite long, but by the time you get to the end of it, you'll realize why flow control is needed in the wireless industry. The next column is multicast. Usually by default that should be on. The next column is MTU. Our default MTU is 1528. The reason why we use 1528 is obviously standard MTU is 1500, but what most people don't realize is most switch manufacturers automatically add anywhere from 18 to 22 bytes to the MTU size to whatever number you give it. We don't. So if you give us 1500, we're going to use 1500, but 1500 would only be good if you were doing no encapsulation protocols, no VLANs, no nothing. If you do anything like that, you're going to increase the header size, and your packets will be too big, and they'll get rejected by the switch. So 1528 is a good number. That'll handle simple VLAN headers and some simple encapsulation protocols, but you may need to increase that depending on what you want to do. The next column is TX limit and RX limit. So we do bandwidth control per port. You can come in here and you can say 512. It says, well, I don't know what 512 is. So as soon as you put a K on the end, though, it says, oh, okay, I know what 512K. So that would be the TX limit on the port. Or you could say 512 megabit by 128K if you wanted to. So it's pretty intelligent as to the answers that you can give it for those columns. The next column is ISO, or if you highlight it, it says enable port isolation. What port isolation does is if I check port isolation for port 2 and port 3 and port 4. So with those on, port 2 could not talk to 3 or 4, nor 4 could talk not to 3 or 2. So these ports can't talk to each other, but any of these ports can talk to any port that's not isolated. And any non-isolated port can talk to an isolated port. So if you check isolation, that means isolated ports can't talk to other isolated ports. So I'm going to turn that off though. The next column, if you highlight there, is DHCP snooping. So some WISPs allow their clients to have layer 2 access to their switches. We don't in my WISP. So the client CPE is always in router or router NAT mode. If it's a residential house, of course it's in router NAT mode. Their valid IP address is on the outside. The radio is in NAT mode. We use access control lists to prevent the homeowner from accessing the radio up top because we don't want them in the radio. We don't want them putting port mappings in and hosting things that they shouldn't host. But if you run a flat network and you give your customers a jack that's layer 2 to your tower, that's your choice, but you might want to enable DHCP snooping. That would prevent them from accidentally offering leases out onto your network. The last column is stats. Basically, by checking this box, that would include each port in these total graphs down here, the total throughput, the total data distribution, the total packet rate down here. So, if you have, say, an in and an out port, you might choose to only include one of those ports into your total overall stats. Once again, the little gear here is also on the end. That's because we wanted to make it quick and easy. If you're going to turn PoE on, you can come over here and do the cable diagnostics first, right? So that's pretty much the ports tab. So we're going to move on to the VLAN tab. Since this is basically a little warehouse, there's no VLANs here. We'll talk about VLANs a little bit later when I show you some of the tower switches that I have at my WISP. But you would basically just add VLANs here if you wanted to, and you come down inside here and you can select what you want something to be. So we're not going to mess with VLANs yet, so we're going to close that. There is a trunk port. Realistically, this header should say, in my opinion, I'm going to see if we can get this changed in the next version, but it should say trunk port or VLAN access list. So if you select that, you can hit OK, and that makes this into a trunk port that would allow any VLAN tag from 1 to 4095. Or you can clear it to turn it off. So This is the VLAN tab. This is the management or default VLAN tab, so it always has to be present. You can change its ID. If you don't want your management VLAN to be 1, you can tell it to be 100. It doesn't matter. But this is the VLAN that the switch interface would respond to. You can change the description as well. This little gear here is grayed out, but if you had another VLAN defined, you could actually click on this gear. And what this does is allow you to assign a secondary IP address to the switch. So in my towers, I VLAN each access point, and then all the access points and client radios are subnetted. So if I wanted the switch to ping the AP as a watchdog, and to reboot the port if it doesn't see the AP, but if the AP is in a different subnet than the switch, then the switch has to get to the AP through the router. So this gives you the ability to allow the switch to access the device directly by putting a secondary non-routable IP address that is only accessible on the VLAN. That way the switch can ping the device that's plugged into the port directly. But it's not really a routable port, so don't try to. You can't. The next tab is lag, or link aggregation. The link aggregation mode is how the switch will determine how to aggregate or divide up the traffic between however many interfaces are in a lag. We'll talk about that a little bit more in detail when we go to some of the other switches in my WISP and at my office, which will have them set up. The next tab is STP. Why this isn't enabled, I don't know. Probably because I was playing with it. But I always recommend that you have RSTP enabled. So I'm going to go ahead and apply that. And so now it's turned on. And what we'll do is we'll see it over here that the ports went to discarding and then forwarding after they learned. And of course, ports that don't have anything are set to discarding. As soon as you would plug something in, the switch would send some BPDU packets out there and bring up the forwarding state. Of course, this is information that you would use for overall switch priority. I'm sure you're familiar with what all these values do, but if not, our switches are pretty standard. You can Google, and Wikipedia has some great references on what all of these little options do. Let's go to the Tools tab. So we have Ping Watchdog. You can have a Ping Watchdog set up. I think I was playing here with this one. I don't even think it actually does anything. Port 10. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's the camera. But I don't think 115 is actually the IP address of the camera. Let's go to the MAC table. And one of the things you'll notice about our MAC table is, of course, we give the MAC address, the port that the device is on, the VLAN ID that the device is on. But then we also give you the manufacturer of the device and the last known IP address. And you can click on the IP address, like say here's our Nano Bridge, that's our router, and that's also our internet access. We can click on that, and it would launch you, right into that device. So we want to see what's on port 10. Port 10 is Ubiquity camera, but it's IP11. So let's go back to the Ping Watchdog, and of course it's disabled. Okay, so I was doing tests there to make sure that it would actually bounce the port. So you can create a Ping Watchdog. I just added another one. I can set a port to it if I want to, or I can just have it, I can just call this, test. I can give it an IP address, 1.14, and the startup time is in seconds. So in other words, from the time that I started, it won't actually fail for 5 minutes, and it's 300 seconds between pings, and it has to have 3 consecutive failures. And since it's not assigned to a port, it won't unpower it, but it can notify me. So you can actually set up as many pings as you want to. And if you have notify selected here, as long as you have SMTP set up in the switch, it will send you a text alert or an email alert to tell you that that Ping Watchdog failed. Like I said, this one was one that I was using to test the ping watchdog feature, so I gave it an IP address that it couldn't find, but I don't have it enabled, so it's not doing anything. Port bounce. Port bounce is a pretty cool feature. Let's say you have a pesky AP or a radio or something that needs rebooted every couple of days, or maybe you like to reboot your equipment once a month. You can say, you know, monthly reboot of AP, if I could learn to spell. When? So you can do daily, you can do weekly, you can do monthly, or just once. So if we do, say, monthly, we can tell it to do it on the 26th of the month at 4 a.m. So it's going to reboot that device by unpowering it for 5 seconds. But you know, I don't want to do that. So it's a pretty cool scheduled port bounce. Maybe you know an AP is acting a little flaky, but it's prime time. You don't want to reboot it, but you don't want to stay up at late at night. You could create a reboot once, and then it would reboot the device once, and at 2 in the morning, and you don't have to worry about it. So what else do we have? Ping is just a little utility to do pings. Trace routes. iPerf. iPerf is a work in progress. It's iPerf 2. At least I believe it's iPerf 2. Maybe it's iPerf 1. And that's pretty sad. But I don't know that, but I'm not the programmer and I don't use it. But iPerf, I do know, is a work in progress. You can enable the iPerf server. This is the iPerf client. So in here you would give it the IP address of the device that has iPerf that you want to do the speed test with. As I said, this is a work in progress. This is slated to be finished by version 1.3.4, I think. So for now, I think we have it limited to 30 megabits because it's just here for testing purposes. And we have port mirror. So in port mirror, you can select what port you're going to mirror, or ports. You can mirror multiple ports if you like, and then you can give a port to destination for the port mirroring. If you notice here to the right, remote host filter IP. So there used to be an option here. It was mirror to IP address. We do plan to finish that and put it back in. We had it in for a while. We took it out because we had some problems with it. But eventually, say you have a customer on interface 10, and you'll be able to come in here and say mirror to IP address. And when you mirror to IP address, you'll be able to come over here and put the IP address of your workstation in, for instance. And then you would put the IP address of the customer. So you're not going to mirror the whole port, but just that customer's IP traffic to your workstation. And then you can use Wireshark with a TZSP filter. And that way you're only looking at the packets coming from that port or that IP address on that port. That's pretty much all the features under Tools. We can go to Device. Under Device Configuration, this is where you would set up the name of the switch. You can put in the GPS coordinates if you want to. This will be used later. This is also used by WISP, which is a neat program that's being developed. You can go read about that on our forums as well. So over here is NTP. So this is how the switch gets its time, because it doesn't have its own internal clock with a battery. So when you reboot it, it thinks it's 1968, I think, or something like that. So this is how it gets its NTP. IPv4, IPv6, these are the IP addresses of the switch. I believe you can have it do both if you like. So you can have an IPv4 and an IPv6 address. SMTP, you have to set this up if you want the switch to do text alerts or email alerts. So you have to enable this and, of course, set it all up, and then there's a test button to make sure it's working. SSH and HTTPS, a lot of you people seem to make the mistake of thinking that if you uncheck this, it's going to just do HTTP. It doesn't. It tells you that. It says if you disable HTTPS, you will not be able to access the GUI. Okay? So we don't want to turn that off. Same thing with the SSH. If you turn that off, it doesn't go to Telnet. It just doesn't work. We don't currently support Telnet and HTTP. So a few people have requested it. I don't know. We might do it. Syslog. You can enable syslog so that everything that goes into the system log will go back to your syslog server. Storm control, you can limit the amount of traffic of particular types of broadcast, multicast and unicast, if you want to. At my WISP, I don't have a problem with this because I don't give customers layer 2 access to my network, so I don't have this problem. Loop protection is not to be confused with STP or RSTP. Loop protection is a special routine, and what it does is it sends out a special BPDU packet out of each port every second. So technically, the switch could send a packet out say port 6. It goes to another switch or some other part of your network, and somewhere out on your other network it's misconfigured, a loop or a partial loop. But if that BPDU packet makes it back to the switch will know that there is a loop out there somewhere because that packet should not have come back. So it will disable that port for 6 seconds. And then after 6 seconds, it'll re-enable it again. And if it still detects that there's a loop out there somewhere, it'll re-disable the port. Of course, it will be sending you text messages each time that happens, so you'll be alerted to it. Of course, it does also work if there's a loop between the switch. So in other words, if a packet goes out port 12 and finds that BPDU packet finds its way back into port 1, it will detect a loop. Now, we did have a bug early on where we weren't taking into account VLANs. So even though a packet was allowed to come in port 1 that went out 12 because port 12 was in a different VLAN, the switch wasn't taking that into account and was disabling one of the ports, but we've since fixed that. So loop protection is cool, but if you ever do run into a problem, you can just turn it off right here. SNMP, well, you guys know what that is. You can enable it. You can select version 2 or version 1. We do 2C. Of course, if you use version 1, you know that there's not any security on it, so that's up to you. Credentials. This is the logon name and the password. Of course, we never display the password there. And you have the option to require the password to console into it. Personally, I don't ever want that option on there. The most common reason I use the console cable is I forgot the password. But if you turn that on, you can't console into it anymore. But my opinion is, if your switch is in an unsecured area, your switch might not be there when you come back. Or, what prevents the user from hitting the factory default button on the switch and chuckling as he runs away? So, but if you really want that option, there it is. It was asked for by some customers, and we listened to you and we put it in. We do support Ubiquiti and Cisco Discovery Protocol. The Cisco Discovery Protocol works great. The Ubiquiti Discovery Protocol, not so great. It's not Ubiquiti's fault. It's our fault. We're just having some difficulty with that module. Let's move over to auto backup. I'll talk about this when we look at my switches at my WISP that are in service, but essentially, if you have a TFTP server on your network, which I do at my WISP, all of my production switches and towers have the TFTP URL in there, or IP address, and then the name of the switch file. And what that does is anytime somebody hits save and apply, it automatically sends a backup copy of the config to the TFTP server. And it doesn't overwrite it each time. It adds a unique number to the end of it. So like say I would go TFTP // say 206.192.87.5 / RF armor. That would be it. That's all I have to put in there. What it would do is actually create a file in the root of the TFTP server called RF armor, and then it would put a extension on that file, a unique extension for the config number. So if I sat here and saved and applied 10 times, there would be 10 copies of that backup in the TFTP server. Radius authentication. I hope Ubiquiti enables this on all their devices soon. If you have a lot of employees, the master credential, you don't ever have to give that out to your employees. And if they log into the switch, they still can't see the password. However, they can change the password, but they can't see your password. That way, you create Radius entries in the Radius server for your employees, and that way if you let one go or they quit, you can just go into the Radius server and delete their account, and they can't log into the switch anymore. A few people have asked us that if they log in with a Radius account that they not be able to change this password and name up here. We are taking that under advisement. We talked about it in the last meeting. There was quite a few reasons as to it didn't make a lot of sense. They're not coming to mind right now, but it is still up for debate, so we may do that down the road. IGMP snooping, you can turn that on or turn it off. iPerf server, so we saw the iPerf client earlier under tools. This turns on iPerf server, and as I said, that is a work in progress. So we've made it across the status, ports, VLANs, legs, STP, tools, and device tab. Under the utilities, you have backup, config, restore, reboot, default, upgrade, and of course log out, and save and apply. One neat thing I want to show you here before we leave this switch is, one nice thing about our switch is, you can come in here and make changes to this switch tab, and then go to VLANs and change some stuff in here. Come back to ports. Your changes are still there, and these changes are still here. What that does is, that allows you to go through the switch and set it all up the way you want to. And since I made changes, the save and apply button is now activated or white. It's ready to go. But I don't want to make those changes. Now, if I would go back and remove those changes, the switch will know that I get back to the original configuration. If I can remember everything that I changed, I think there we go. So as soon as I put everything back the way it was, the save and apply button went gray. So another thing you can do, you make a lot of changes and you go, oh crap, that's not what I want. You just simply hit the refresh button on your browser, and it will reload the config from the switch, and you're back to whatever the running config is. I guess before we go to some of my WISP switches, one last thing I'll show you here is we do support a CLI interface. So I'll bring up PuTTY here, and I can log in. Well, what that's telling me is that this connection timed out, so we're going to restart the session. So here's PuTTY, so I can log in to this switch, and there we go. So I'm logged into the CLI. I can hit a question mark here, and I can get a list of commands. Then I can say go into configure, and then in here I can hit question mark and get a list of commands. So let's say I want to let's change something kind of small, maybe, or just maybe go a little bit further down, let you see what it does. So let's go interface. So we can go interface and hit question mark, and then it'll let you drill down. So you can say, okay, interface port, question mark, and then I can say, okay, I'm dealing with port 2, question mark. So what can we do here? Port 2 disable. Okay. I look kind of silly here. I don't really use this. So port, oh, I'm sorry. Port 2. Okay, now I'm in port 2. Hit question mark. Now here are the options that you can use to configure it. So I could say, okay, I want to, what do we want to do to it? Let's enable port isolation. That sounds cool, right? So we say isolation and hit question mark. So all we have to do is hit enter. And so now it's port 2 should have isolation on it. And then we will control Z out of it. It'll take a second. It will apply the configuration. And now you'll notice that on my web UI, this little drop down happens. So if I was working in the switch and somebody else was logged into the CLI and they made a config change, this would drop down and tell me that the configuration has changed. And so I have to click on it to tell it to reload. But if we go to ports, we'll notice now that isolation is on. So we'll turn it back off. So the CLI is complete. You can do everything in the CLI that you do in the UI. I'm not an expert at our CLI. As you can tell, I have to muddle around in it because the web UI is so much easier. But for you Linux heads that love to mess around there you go. One other neat, cool thing you can do, at this point you're in our shell, but you can type CMD, and that drops you down to the Linux shell. So you can do an ls, and there we are inside Linux. And then whenever you want to go back into our command, you just type in exit, and then now you're back inside of our little shell. So that's pretty cool. It is a full CLI. It is full SNMP, as we also talked about. So let's go look at some of our other switches. First thing I'm going to do is show you a switch I have set up over on the bench, the testing bench. So I'm going to use radmin to get to that. So it's going to make the screen a little bit funky here for you in a second. But that's the only way that I can get to it. Okay, so that's not the right one. Give me a second. And we'll go log into it. Okay, it's a little bit bigger screen. Probably don't want to see it that big, but it is what it is, people. This is our 12-port DC switch you guys might have heard about. It's a really, really cool switch. It's the only switch on the market like it. What makes it special is you can feed this switch any input volt range that you want between 9 and 60 volts and still power 24 and 48 volt devices. So let me bring up a little crappy picture that I made for you to show. But so like this is our DC switch. It has two little DC lugs in front of it. You can have a 24 volt site fed into it, or you could use a single 12 volt battery and feed it, or 36 volts or 48 volt. It doesn't care. So you hook the switch directly to your battery bank, and when you do, it allows you to power 24 and 48 volt devices. So now I'm powering this with just a 50 volt power supply. So if I come into the status tab, it tells you that the input power is 49.9 volts. And then the output from the power supply to the switchboard is 49.6. So it's actually not doing very much work. The switch will calculate its efficiency. It's not very efficient when it's not doing very much, and it's not doing very much right now. As you can see, the total power output of the whole device is 12.1 watts. But in this data screen here, you can see the board voltage for 24 volt output, 3.3 volt, and of course the 49 volt or 50 volts is our standard PoE. As I said, we call it 48, but we actually output 50. The fan RPM is here. I guess I forgot to talk about that on the last thing. The cooling fans have tach readings, so we monitor their RPM, and if they start to fail, or they do fail, we'll send you an alert if you have SMTP configured, or if you're monitoring it through SNMP, you can have it alert you that a fan is failing. In all of our switches, we tell you the board temperature, the CPU temperature, the PHY temperature. Now, and this is a DC switch, so it's actually telling you some additional information. It's telling you the power supply temperature and the heat sinks and the controller chip temperature. And then also, this DC power supply has its own processor, its own firmware. It's telling you I'm running an RC version here, so if there's any bugs I come across, it's because this isn't released yet. Since I don't have the NTP server set up, this switch thinks it's 1970. Let's switch back to the other switch I was showing you, since I missed that. Let's go into the status tab. Now this is an AC switch, of course, so you don't have any of the other settings that you saw before, but you have the fan RPM and the board and PHY temperatures. Of course, this is also running the RC candidate. It's board rev C. Now this one has the NTP time server, so it knows what time it is. The CPU utilization. I want to talk about that. A lot of people say, "Oh man, your switch is pushing 800 megabit and the CPU is hardly breaking a sweat." That's because the CPU doesn't do anything except run the UI. Switch cores are self-contained units. So when a switch manufacturer like me, Netonix or Ubiquiti or Linksys or Netgear. When they buy a switch core from the manufacturer, the switch core is self-contained. It has its own dedicated processors and its own software that runs the core. If there is an embedded CPU like our core has, which is a MIPS 24K-C, 416 megahertz, that CPU is only meant to drive the UI that you're looking at here. It's what configures it. There are some daemons that run on it though, things for like RSTP or LACP that control those functions. But as a whole, all the real work is done by the core itself. The CPU has nothing to do with it, which is why when the Ubiquity Titanium lines came out and everybody said, ooh, it's got a bigger processor, ooh, it's got more memory, it's like, look, if you have the access point configured in bridge mode, which you should, unless it's an endpoint, such as a client, it should be in bridge mode. Let the AP be an AP, as Wyatt used to say, or Justin from the Ubiquity forums, and use a router to be a router. So if you had the AP in bridge mode, the packets went right from the wireless interface right to the Ethernet interface. They never touched the CPU, so the CPU really had no bearing. Of course, somebody like Jim might argue that, oh well, Sirhc used it for TDMA. To a limited extent, yes, but not any amount of CPU made any difference in that aspect. So anyway, that's the device status tab. What else did I possibly miss? We talked about the MAC table. Oh yes, access control list. So our switches have a tar pit. By default, it's enabled. So the user has 5 attempts to log in, either in the UI or the CLI. If they miss or mess up those 5 attempts, the switch will delay 60 seconds from the offending IP address. So that means if you and another guy are trying to log into the switch and he's messing up over there, but he's at a different IP address than you, his IP will be blocked from the switch for 60 seconds. You can log into it right away. You can disable it if you want, but I would not. You can also make it stricter or laxer if you like. It also has an access list. So you can add rules. If you don't have any rules, the switch will allow any IP address that can route to it to attempt to talk to it. But you can put in these access lists. But I warn you, if you're putting in the access list, you want to also make sure that you include your SNMP server, your SMTP server, anything or anybody that wants to talk to it will need to be in this access list. So, if you're going to use this, think it through. But it's there. Console, that's basically just allows you to get to the CLI from inside the web GUI. You can also drop down to the Linux level from here, and then you can exit out of it, and it logs you out, so I have to connect again to get back into it. We talked about the MAC table, which is cool. That's pretty much it there. So let's go back to our cool DC switch. So the DC switch, obviously on the status tab, has a little bit more information because of the power supply. Now the power supply, the DC power supply is smart. It can take from 9 to 60 volts in, still allow you to power 24 and 48 volts out. And it can take, so you could start off feeding it 53 volts, and then as your battery's depleted, you could deplete your batteries all the way down to 9 volts if you wanted to. Of course, that's an argument too on the forums about how deep of a discharge will roll in a battery. My argument is we give you the option to run your batteries into the ground if you want to. And it doesn't mean you have to. And we'll talk about that a little bit more on the powers tab. But so the rest of the switch interface is exactly the same as the AC versions. The only difference is going to happen when you get to this power tab. And this is what I was talking about, the ability to run it into the ground. So by default, the switch is set up to run anywhere between 9 volts and 60 volt input. Now, of course, it won't power up at 9 volts because we don't want it powering up at 9 and then shutting off at 9. So the minimum to start the switch is 10 volts. But once the switch is running, it will run your batteries down to 9 volts. But let's say you have a 24 volt battery bank. Some people say, well, gee, I don't want to run it down below 20 volts. So you would set a warning volt at 21 volts. You would tell the switch to hibernate at 20 and then wake back up at 21. I mean, the wake up voltage has to be 1 volt higher than the hibernate voltage. And what that's saying is, if you have this hooked to a 24-volt battery system, when it gets down to 21 volts, if you have SMTP set up, it's going to send you a text message and say, hey, I'm running low on power. When it gets down to 20 volts, it's actually the power supply, which has its own processor, is going to tell the switch core, you need to shut down. And the switch core has to shut down, and then the power supply will actually shut the switch off. Now the power supply will stay running, and when the power supply detects that the input voltage is high enough, it will actually wake the switch back up, and then the switch will send you a message and tell you, hey, I'm waking up. But before it gets to that point, so let's pretend that we have a 24-volt battery system in here. So one of the things that the switch is going to require you to do is set a priority on the port. The higher the number, the higher the priority. So as the switch is running out of power because your batteries are getting depleted, if you don't tell it to, it will shut ports off least priority will shut off first, and the highest priority will stay on the longest. But you could come into this switch here and you can say, well, look, port 1, let's go back to ports here, and we're going to say, we're just going to call this air fiber 24 backhaul. We're going to kind of mock this up a little bit. And, we've got it set to 48 volts high input, and then let's call port 3 backup link, and it's just an M5, and that's 24 volts. I'm not going to save it. Well, okay, we'll go ahead and save and apply that. It's not going to hurt anything. So you'll notice on the Christmas tree that those ports now are set up for it. And we go to the Powers tab, and so it's telling you that, okay, port 1 is your air fiber 24 backhaul, port M5 is your backup link. So, we're going to want our main backhaul probably to be, a lower priority because it's a power hog, but we would probably want our backup link, which is a low power link, to have the highest priority. So we'll put this one at 3, and we'll put this one at 12 because it's a mini, and we'll set this guy down here to 2. So every port has to have a different number. You can't give things the same priority. And what it uses that for is, the smart power supply has 250 watt capacity, but that's if you have at least 18 volts of input. Once you get below 18 or 15 volts of input, it drops down to 150 watts of capacity. So if you had the switch fully loaded up and you were exceeding your budget, as the DC input voltage on the switch got below that 18 or 15 volts and its budget went down, it would turn off ports automatically for you. But you can come in here and say, hey, if power is getting tight, I'm down to 22 volts, shut the air fiber off and don't power the air fiber back up till you get to 23. And if you don't give it a voltage, power down and power up, the switch will keep it up as long as it can. But then again, that's where the priority comes in. Another thing you can do in here is you can say, I don't need this air fiber after midnight, so at 12 a.m., shut it down and bring it up at 6 a.m. Now, that's assuming that you have RSTP or maybe OSPF or something running, so that when this air fiber backhaul goes down, it fails over to the backup link, which of course uses a lot less power. So there's a lot of controls in here for the DC switch. Now, you do notice that the DC switch is running a WS6 Mini, which is another one of our switches, which is cool. The WS6 Mini is basically that. It's a 6-port switch. This one here is being powered by PoE in on port 1. So it's actually getting its power from the DC switch. So you could run one wire up the tower to a WS6 Mini. It's being fed, it's being fed 46.8 volts at the end of that wire, which is enough to run, 48 volt PoE devices. And then you have your 24 volt output. So, you can come into your ports tab. Now, port 2 is a special port on the 6 Mini. It only gives you 24 VH and 48 VH. But I do want to warn people, on the 24 VH option, do not try to power an AirMax or a 10100 device with 24 VH. You will fry the port in the switch and you will fry the device. 24 VH is primarily made just for air fiber X's, And you only need AirFiber 5X 24BH if you're running more than 150 feet of cable, because you can easily power an AirFiber X off of 24 volt 0.75 amp. So this is the 6 Mini. The nice thing about our smallest switch, which is our 6 port, to our 12 ports, to or even our 24 ports, is they all use the same switch core. They're the VCS or VSC 742X family. And if you go to Vitesse's website and read about the switch cores from their PDF, it'll tell you that it is an enterprise class switch core, entry-level carrier grade switch core. Like the Tough switch, which is a good switch, but if you go to Broadcom's website and you read the PDF, it's based on the Tough Switch Pro is based on the BCM 53118, and then now its successor. Broadcom tells you that switch core is designed for SOHO applications, not carrier applications. So with that all being said, this is the 6 Mini. It's a cool little switch. So let's continue on. So, I run a WISP, and here is my NOC, my Network Operations Center. I have two 24 400As here, and they are connected together, and they're using a lag to achieve that. So I took port 25 and 26. I used an LACP lag. We support LACP A or P, which means active or passive. All active and passive means if I'm an active LACP, it means I advertise. If I'm passive, I don't talk. So you can't have LACP P or passive on both sides because they're both shy. Neither one will initiate a conversation with the other one to say, hey, do you want to combine our two ports here? So one side has to be active, but you can have them both active if you want to. This is the other switch, and I have it. Oh, it is set to passive right now, but they can both be active, or one can be active and one can be passive, but they can't both be passive. You have to assign a key or a lag ID. Of course, I'm using lag 20, so if I come to the other one, it's also lag 20. Now you'll see I have another lag in this switch too, which is another LACP lag, and that's actually talking to an Edge Switch Pro, or an Edge, I'm sorry, not an Edge Switch Pro, an Edge Max Pro router, Ubiquiti. So it has, and it's in group 10. Now if we go to the ports tab, you'll see I have flow control turned on all the ports. But if we go to the status tab, you'll notice that I have a 1 gig link to the Edge Router Pro, but I don't have flow control negotiation. That's because up until just the latest version of the firmware of the Edge Max routers, they did not support flow control. And my network operations guy, Tom, hasn't installed the latest version. So you'll notice that it has a 1 gig connection, and the lag is up, but there's no flow control. And in the wireless industry, you want flow control. There's a great post, like I said, on the forums. Go read that. But you can see here that all of the links that are connected to a device that can negotiate flow control, it is. So here's my Exchange server. It has a 1 gig connection. Flow control is initiated. That's what the FC is telling you. Down here is an HP laser printer that's somewhere in my office, and it only has a 100 meg connection, but there's no flow control. And so the FC is going to tell you when you have flow control. So these are the switches in my office. Like I said earlier, a cool thing about our switches MAC table is it tells you all the manufacturers of all the devices, and you can sort on that. So if you're looking for a Ubiquiti device, they're all there. Or if you're looking for an HP printer, you can find it alphabetically or based on the MAC or VLAN ID. It's all there. So that's my Network Operations Center. This was the 6 Mini. This was the 12-port DC. And let's go look at some of my live towers at my WISP. So this is what we call Quarry Road. This is the one of the main towers in my operations. All of my towers have a 24-port WS24400A. They are the older version. Obviously, I've had these switches in service since the beginning. So my switches went in service in August of 2014 before they were for sale to anybody. And so they're the older versions for sure. So the older versions of our 24 ports only offered 0.5 amp per port and 1.2 amp on the HP or VH ports. All the current switches we sell, every model, 48 VH is always 1.5 amp, and 24 and 48 are always 0.75 amp across the board. But if you're using 24 volt on the first 4 special ports or 48 volt, it's also 0.75 amp. But we tell you in the PoE configuration. But like I said, this is an older model, an older revision. Everything in the switch is the same as the new model, except we just increased the polyfuse rating and the Ethernet transformer rating. So, but you can see that there's about 600 megabit of traffic on this switch right now. And like I said, I like to kind of laugh at people. You know, it has no bearing on the CPU utilization whatsoever. So here it is. I'm powering, this is an AirFiber 24 that's going to Stumptown, which is where my AirFiber comes in from level 3. You guys might have read the post on Ubiquiti's forum called Life After AirFiber, which is actually talks all about that site. This is an AirFiber link going one direction on the ring. This would going towards Akron, Pennsylvania. This is an AirFiber 24 headed into Hillcrest or in downtown Leola, Bearville, which ties in by fiber to where my network operations center is. And then this is a 48 volt SAF link that's being shot over to a dedicated customer that's paying me for a 100 meg connection. It's a very nice monthly income. And this is another private connection in Lancaster to a law firm. That's a nice connection. All of these are access points. So, you know, QR20 is it's a 2.4 access point, 21, 22, and then these are 5 gigahertz, 50, 51, 52, 53, 54, 55, 56, 57. Obviously, some are 5.7 Uni 3, and some are Uni 2. The M5 sensor that's in the box. This is a lag that goes to the Cisco router that feeds all of the locals. Let me explain that a little bit. So this is a generalization of how my tower is set up. So the AirFibers are generally set up in a midspan. That means that, say, port 26 and port 25 and port 1 are in a VLAN of themselves, which turns it into a midspan injector, sort of. Port 1 obviously has the PoE option, which, if you follow the line, that's what's powering the AirFiber 24, and then that's bonded to port 25, which is an SFP module. How you put copper module in it, or fiber, you can do whatever you want, and then that goes to a routed point in my router. And then the same thing is done for the other AirFiber going out. Now, some towers have 3 and even 4 AirFibers, and they're all done in midspans, but this is essentially how that's done. This is a representation of the Cisco 2951 that's in the tower. So then I take the 2 built-in ports and I create a static lag that comes into the switch here. Now that static lag is to feed all of the access points and private customer radios that are on the tower. So they're designated in yellow. Green is for the lag, and in this situation, purple and other purple is the midspans. So we'll go back to the switch there again and see a little bit more about that under the VLAN tab. So if we go to the VLAN tabs, so like here's this AirFiber. So if I highlight that VLAN, you notice it highlights the 2 ports up here. So it's telling you these are the 2 ports that are in that VLAN. And what we did was we put a U on port 1 and we put a U on port 25 and exclude on all the other ports. So essentially that separates out those 2 ports from the rest of the switch. They're like a private 2-port switch or a midspan injector. So that's one AirFiber that goes to where my fiber pop is. And then this midspan here is a AirFiber 24 link, and you can see it highlights them up here. That's going to Akron, so that's one direction on the ring. And then this is the other direction on the ring, which there's another midspan. And then you can see that that leg that we created to feed the local radios is using port 22 and 23, and it's a static leg because Cisco doesn't support LACP unless you're talking about a Cisco Catalyst or a switch card, and so we don't have that, so we're doing a static leg. Static leg and LACP are very similar. The only difference is LACP kind of sits on top of the static leg. It's a control daemon, basically. So static leg is just that, it's static. There's no failover or nothing. So if I lose one of these interfaces on a static leg, I'm kind of screwed because half the traffic's going to go nowhere. The other half will get where it's supposed to be. So with LACP, one could fail. I guess I can demonstrate that to you. So if I go back to my office here and we go under lag, so you can see here that there's an LACP lag between the two switches. Now, if I go into the ports tab and disable, say, port 26, and we come back to the lag tab. Now remember, I made the change there, but I didn't apply it yet, so I'm coming back to the lag tab, and I'm going to save and apply, so that's going to disable that port. Invalid field somewhere. Well, I am running a... Where do I have an invalid field? Let's just refresh that interface. Maybe somebody was messing with it. So let's go back to the ports tab. We're going to turn off port 26, go to the lag, and we're going to hit save and apply. So it's saving it here. Now what you're going to see down here, you see how it went inactive? And if I bring up a ping, this was a ping to the other switch. So it missed one ping while it actually failed over to just one interface. Now if I go back to the ports tab and re-enable that, and we'll go back to lag, and we'll hit save and apply, and we'll bring up the ping. So if you watch here, you'll see that it should go active. Now you may miss a ping, sometimes you don't. It depends on how the aggregation is going at the time, but you see it went back. So that's where LACP will fail over to one interface. In a static environment, that doesn't happen. You lose one of the legs and you're kind of in trouble. So where were we at? Okay, so this is back on Quarry Road Tower, and that's the static leg that I talked about. But, how often does an Ethernet interface fail? You might say, well, why did I create that leg to feed all the local radios? So remember, the backhauls aren't going through that leg. The backhauls are done mid-spans directly to the router interface ports. The only thing going through the leg are all of the little radios. So let's go back to the status tab. So you'll notice that flow control is active on all of those ports. So, but if I go to, say, QR52 and we do a port detail, you're not going to see any pause frames here because it's not like the Ubiquiti M5 is going to be able to shove so many packets at my port that my port can't handle it. But what can happen is a whole bunch of packets could be coming from the internet destined to port 15 or QR52, which is also VLAN 52, that it overwhelms the buffers on port 15. Now, the switch core that we use has flow control with back pressure, and it has dedicated processors it doesn't wait for the buffers to overflow on that port. So there's actually a routine and processors monitoring that buffer space, and when it estimates that the buffers are going to overflow, like maybe it says in its algorithm, it says at the current rate of packets coming, my buffers are going to overflow in 2 microseconds or 5 microseconds. So it's going to preemptively send a pause frame to the source of those packets to tell it, hey, whoa, slow down for 50 microseconds. So port 15, if we go to the VLANs, which is VLAN 52 right here, and there's port 15. So that's the untag interface. So that means packets coming out of that port to the AP are untagged, but they're going to be coming from those 2 ports that are on that static leg, which are on port 22 and 23. So each access point is its own VLAN. So that means in the Cisco router, we would create sub-interfaces or VLANs for each AP, and that way all of these secondary IP addresses for the customer's default gateways would be assigned to those VLAN or sub-interfaces in the Cisco, but they would get sent to the switch as a tagged packet from the Cisco, and so they enter in these two ports with the proper tag on it. So if it comes in with VLAN tag 52, so it comes in one of these ports, it goes up and it says, okay, I go out port 15, the switch says, oh, that's a U, so it takes the tag off of it and pushes the untagged packet to the AP. And now that packet goes to the AP, which of course is layer 2 bridge, and the access point sends it out to the customer, and then it goes into their NAT router that they have on their end. But so many packets can be destined to that access point on that interface that it's going to overflow its buffers, because the switch thinks it's a 100 meg full duplex interface, but in reality it's a 20 megahertz Uni 3 band, so 70 megabits if we're lucky, could easily overwhelm those packets quickly. So the switch detects that those packets are going to overwhelm the buffers, so it sends a pause frame to the source. So it's going to send that pause frame back to whichever interface it happens to be using at that time, and that's why all this long discussion, why I create a lag, so that there's a 50-50 chance that that pause frame won't affect any of the other APs. Now that pause frame is very small anyway. We're talking about 50 microseconds. But still, with that many access points, as you can see I have, and that many potential customers, by adding a trunk or lag to split those pause frames up, is a 50-50 chance that one pause frame won't affect anybody else other than those that are on that interface. So let's go back to the status tab, and we're going to go down and look at that. So remember, on the interface facing the AP, we're not going to see any pause frames because there's no reason for that. But the interfaces facing the router on the lag, those are going to have pause frames, because those are going to be where the switch is telling the router slow down. Now let's look at port 22. So port 22 has 24 million pause frames. But let's look at port 23, which is in the same lag, but it should be a totally different number, and it is, because that means depending on which trunk in that leg or which port in that leg that any given access point is using at that moment that the buffers overflows, only that interface is issued the TX pause frame. And so the switch is sending this pause frame back to the Cisco router interface, telling that router interface to pause, and only that interface. Now, which is kind of nice. Everything works great. I love my network. So it works out great. But let's go and see, what was I getting ready to show you guys? I don't remember, but so once again, that's the lag for all the local radios. There's the VLAN tab showing you how I do the midspans for the backhauls, and then how I do the link aggregation to feed all of the local radios on that tower. All the APs, all the private point-to-point radios for high-end customers, etc., etc., etc. Of course, I have STP enabled. I highly recommend, if you're going to use lags, LACP and stuff, turn STP on. It just solves a lot of problems. It prevents momentary loops and stuff like that. Some people say, oh, it masks a problem. No, it doesn't. It's what it's designed for. Turn it on. It's the best thing to do. I'm not really sure what else to show you. This switch is honking on. Other than the fact that look, there's an air fiber, 0 errors, 0 errors. Here's another air fiber, 0 errors. Here's SAF. So there's no errors. If you do your cabling and stuff right, you're not going to have problems. But anyway, this switch at this tower feeds the next tower, which is this one. This is Hillcrest. This is the one also that has the fiber connection to my NOC. It's also powering 2 air fibers. That would be the one coming from Quarry Road, and then the out from Quarry Road to Bearville. Now there is also a backhaul that shoots about 10 miles, which is using a Rocket M5, soon to be replaced by an A5 probably an AirFiber 5X maybe. Now there's also a SR. So Quarry Road here has an AirFiber 24 link to Stumptown where my fiber is, and then Hillcrest has a Mimosa link also to Stumptown. That's my backup link. And so a few months ago, you saw a post where the AirFiber on Quarry took a lightning hit, my first lightning hit in 4 years, and died. And everything switched over to the Mimosa link, and the Mimosa link worked like a champ, and it held my network up. So you can see there's no traffic here right now. You know, I'm going to be real brave here and show you guys something. Hope I don't regret it. So this is a ping to 8.8.8. I'm going to, it's midnight, so it's not too bad. I'm going to go back to Quarry Road. We're going to simulate a failure. So we're actually going to disable my main fiber connection through the main AirFiber 24 connection. So we're going to disable it, and we're going to bring up our pings real quick. And we lost one ping. We lost one ping, and now we're failed over to the Mimosa link. So if we go back to Hillcrest, now you see the traffic picked up on the Mimosa. So Mimosa is now carrying my backhaul for my entire network, but it is midnight and it's not so bad. It's only a couple hundred megabit. And then we're actually going to fail it back over. We just come back into this one and we tell it, you know, you saw the X up here. That's telling you that it's disabled. We're going to go ahead and save and apply this. And let's bring the ping up. And we should see the latency drop. Now, with the Mimosa, you do get a little bit more latency spikes. You see that one there at 138. Because it's a half duplex radio, where the AirFibers are full duplex, they're much more resilient. So let's go back to Quarry Road here. And you're seeing the traffic should shift over here to the AirFiber. And it is. And we didn't lose a single ping on the transition. So that's pretty good. Alright, so Stumptown comes to Quarry Road. Quarry Road feeds Hillcrest. Hillcrest feeds Bearville. This is the next tower in the loop. So, once again, no errors. I don't know what to tell people. I see them on the forum. Hey, I'm getting errors or something wrong with your switch. I'm not magical. I don't do anything different. Now, the only thing I don't do is I have no surge protectors. I'm all about grounding, as you guys know. Which, if you go to my forums and you come down to search corner, there is a link here called site grounding. I spent an awful lot of time, guys, on this post. So go visit my forums and read all about site grounding. But I don't use any surge protectors. I don't like them. They cause problems. They're insertion loss. They're going to cause dB loss in your signal. So anyway, this is the next hop out. So you can see, that's Hillcrest. Now we're at Bearville. So Bearville has an AirFiber 24 pointing back to Hillcrest, and then it has one pointing to Diller Avenue, which is the next water tank. And, I never turned on, this is an older version of the firmware, I believe, here. Yes, this is 132. So if you notice here, it doesn't tell you that flow control status, whereas if you look at the newer firmware, it tells you when flow control is active. So this is an older version of the firmware. This is where I tell you guys, upgrade your firmware. But still, no errors, everything's cool. Now, Bearville shoots to Diller. Diller has updated firmware. So each hop, we're getting a little further out, so if you look at, the overall usage, as you come further and further out my network, so we deselect everything. So, at the head end here, we're at 600 megabit. You go one tower out in the ring, you're down to 5. You go another hop out, you're down, it drops pretty low, down to 1 something. Until you hit Diller tonight. This is the tower that's feeding where I'm sitting at RF Armor. It's about 2+ miles from me, maybe 3, that I'm shooting into. Once again, no errors. I think I'm on that one. I'm not sure. It's one of these access points that feed me. All the way to me. So what else did I want to talk to you guys about? We talked about the cool DC switches, the smart ones. Now, we do offer a smart DC, which will take 9 to 60 volts. We offer what we call the dumb DC. That means it expects conditioned power. So you have to feed it 48 volts. That would be the WS-12-DC. The smart one is WS-12-250-DC. We talked about how I set up my legs and my towers, how everything works there. Basically, our switches use the 8023AF standard pinouts. So this top picture here is from Wikipedia, showing you the pinout polarities. This shows you the pinout polarity from our PDF, which is pretty much the same. I'm not saying I plagiarized it. But anyway. So, anything else? Our WS6 Mini, a lot of people ask questions about that. It has, so you can feed this thing with a PoE in on port 1. The nice thing about port 1 is it has a bridge rectifier circuit on it, so you can use pretty much any PoE brick. So it'll accept the Airfiber 24 or Airfiber 5 PoE brick as long as it's 48 volt, all 4 pin. But you can also use a Mimosa power brick, even though the pinout polarity is backwards on 2 of the pair, because this switch has a bridge rectifier circuit, so it will take care of that for you. You can also power the 6 Mini with a barrel connector if you choose to. So if you want to hook it into a DC supply that you might have at your site. Well, I hope I've answered some questions. I'm sure that I did a poor job at this, but it's been an hour and 22 minutes. I'll try to do a better one next time. It's been a pleasure. I hope you guys enjoyed this movie. Good night.